formula here, we're going to deal with our first learning goal, which is I can describe, we only have one in this class, sorry. I can describe how changing the slope and the y-intercept affect the graph of a linear function. So what happens to the line when we change the slope? What's the new line? How is it affected? What happens when we change the y-intercept? How is it affected? So first of all, we got to run through some things that we need to know. A set of functions, so we have this group of functions. Remember, think of it as equations, whose graphs have basic characteristics in common, is called a family of functions. Just like you come from a family, there can be a group of functions that if they have the same basic characteristics, they make a family of functions, okay? All linear functions form a family because all of their graphs have the same, all of their graphs, I don't know what I mean, what I want there. All of their graphs have the same basic graph. I guess that's what I thought, but it kind of seems redundant here, which is what? What kind of a graph do linear functions have? Benton?
Straight line.
Yeah, lines, right? Okay, so we have the linear function makes up their own family. The most basic function in a family is called a parent function. So the most basic one is called the parent function. And in a linear function, the parent function looks like f of x equals just x, or also known as y equals x. So you know what, let's just go put that into our calculators and see what the function of the linear family looks like. So in the y equals screen, clear out everything that's in there, and just type in x for the y sub 1. This is the parent of the linear function. Okay, what's it doing? What's its behavior on this graph? Give me some information about it. Going through the origin. Why would it go through the origin? Because what? Has no points, did you say? It has no, what is its y-intercept? I think that's kind of what you mean. What's its y-intercept? 0, right? It has nothing being added to the x term, so its y-intercept is 0. So that's why it's going through the origin. What else is it doing? Going up from left to right. Why is it going up from left to right? Come on, stop whispering. Why is it going up from left to right? As a positive what? Correlation, also known as slope, right? Has a positive slope. What is the slope of the parent function in this case? What is its slope? 1. So it's rising at a rate of 1 as it's running at a rate of 1. Whether that is 1 both times in a positive direction or 1 both times in a negative direction. Okay, go ahead and turn those off. We'll just leave that in there for now, okay? Well, the graphs of all the other linear functions, so not this parent function. Now the parent function is the most basic one. The graph of all the other ones that are in the family are transformations of the parent function. So the parent function gets transformed to create members of the family, other members of the family. And by the way, this is just a one-parent family. That's just one parent, f of x equals x. Okay? So the 3 types of transformation that we're going to deal with are translation, rotation, and reflection. So a translation, I say AKA, in other words, what in our typical everyday language, instead of saying translate, something translated, what word do you think we would use? What's a translation mean? What happens? Anybody know? From prior math classes? It's also known as a slide. So it slides. Every point moves the same direction and distance. Every point moves the same distance and direction. Rotation. You got an AKA for that one, I think? A turn, yeah. Also known as a turn. So when something is rotated, it is turned. Well, note what it says there. That's important. The slope changes when we have a turn, when we have a rotation, but the y-intercept does not. So to turn it, the only thing that's happening is the slope is changing. To rotate it. Reflection, anybody know what that another name for the AKA for that one might be? A flip, yeah. Also known as a flip. When you reflect something, you flip it over. So a move across a line that produces a mirror image. Okay? So we have those three types of transformations that we're going to deal with in transforming our linear parent function f of x equals x, or y equals x. So when we have linear functions written in slope-intercept form, so this is how we can tell when they're in slope-intercept form. For vertical translation, remember that's a slide. Vertical is which direction? Up and down. So for a slide up and down, what would have to change? The slope or the y-intercept? The y-intercept, yeah. So for a vertical translation, for a vertical slide, for the points to slide up and down, the y-intercept changes, but the slope does not. So if the slope does not change, only the y-intercept does, we look at it and say, oh, that means there was a translation that occurred. For a rotation, now it's the slope that's going to change. And it says right here, the larger the absolute value of the slope. Absolute value meaning what again? What does absolute value mean? I wonder how many times I've asked this year. Absolute value is how far it is from 0. And it's always positive because we don't talk about. So what's the absolute value of -7? 7 is 7 units from 0. What's the absolute value of 8? 8, because it's 8 units from 0. So the larger the absolute value of the slope, so we're going to look at that slope, we're going to say, if I took its absolute value, and I compare it to another one's absolute value, the larger one, that means the steeper the graph. The smaller, the less steep. So when the slope is affected, I'm going to look at which one has a larger absolute value and compare them that way. And then for a reflection across the y-axis, that's going to be the line that we're going to reflect over. You can't reflect over other lines. Thank goodness this year we only have to deal with the y-axis. So it's going to flip from one side of the y-axis to the other. Flip from one side of the y-axis to the other. That's the only type of reflection we have to deal with. And when that happens, the slope has been multiplied by a -1. The slope has been multiplied by a -1. That's what created the slope. So let's see if we can do the fun right now. Since we have the parent function, let's see if we can flip the parent function. Oh, turn your calculators on again. In y sub 2, I want you to put in the equation that you think would flip that one. It would reflect it. It would make a mirror image of it across the y-axis. So type in. Avery did it. Anybody else got it? You got it? You got it, Colin. You got it, Chase. Okay, why don't you do a zoom 600 Easton and then I'll give you a better window as well. Okay. Looks like you got it. You got it? Hey, I'm not going to go all the way around the room. I want to hear from you guys over here, because these guys got it. What did you put in for a function? -x. Because the slope of the parent function is 1. What's 1 times -1? 1 times -1? -1. So therefore we need to put in a -x, and then it will be a reflection of that line. Okay? So now I want you to, let's just play around and see if we can get some other things to happen. Go ahead and take that out of y sub 2. Let's take the parent function, just have the parent function in there again. And now in y sub 2, I want you to create a translation up. What equation would you need to put in, do you think, to create a translation up? Go ahead and type that function and see if you can just, play around, see if you can make this happen. In your notes, what did it say? To create a translation, what has to change? What has to change? What changes? In a translation, because we're creating a slide, a translation, and I want it to slide up. What? Does the slope change? No, that's the thing that does not change. It's the y-intercept. That is. Anybody got a function that you have in y sub 2 that created a slide up? Okay, Natalie, what's your functions? What's your y sub 2 functions? Name them.
Okay, x plus 2.
X plus 2. X
Plus 3.
X plus 3. So in other words, we need to add a number to x that is positive, right? So the y-intercept right now in the parent function is 0, but if we add a positive number to it, it should slide that line up. It should be crossing. Every point should just have moved up. Every point in that line moved up that many units. Okay? Okay, how about you try? Go ahead and take your y sub 2 off. I want you to try and create a rotation. Create a rotation of the parent function. That one easy? 5x. Okay. So which one is steeper? The one that it has been transformed, or the parent function? The one that has the 5x. Okay. So it turned it. Do they still both have a positive slope? Yeah. Do they have to have opposite slopes to be rotated? No, they don't. So you need to change the slope of the line, don't you, to create a rotation. Can you use a fraction? Okay, let's try that in fact, because let's try and see if we used a fraction like maybe 1/2 or 1/3 or 1/10 or whatever. Instead of something greater than 1, let's do one that's less than 1, between 0 and 1. Do we have now a line that has turned and is less steep? Is it flatter than the parent function? Yes. Okay. So these are the kinds of things that we have to keep in mind that should happen when we do transformations. Okay. So far, any questions? Okay. Why don't you go ahead and turn those off, and then we'll use them again a little bit here, maybe. Okay. Number 1, describe the transformation or transformation. Sometimes more than one transformation occurs from f of x to the graph of g of x. Okay, g of x just means we have a new function that's going to be in this same family. Okay, so f of x is the first function, g of x is the second function. They're both family members. Is f of x equals x, is that the parent? Yeah, so we're going to transform the parent function by doing something to it and getting g of x, which is x minus 4. What transformation occurs here? Transformation occurs from f of x. You always start with what it was before we did anything to it. Okay?
Translation.
Translation. And then when we describe a translation, so go ahead and put that translated or translation. You can use either word. Translated or translation. Just don't use the word slide. We're going to get more formal than that. Translation, but when we talk about a translation, we have to talk about how many units and what direction. So what did it translate? How many units take? What should we expect on the graphing calculator if we put this in? 4 units, originally figures up here for you. 4 units, what direction? Down, because it's subtract 4. So if we change that to add the opposite, it would be plus a negative 4. So we are dropping down 4 units. So we're going to say translation 4 units down. So this is what you have to do. You have to describe direction and how far, also along with your translation. Okay? Okay, go ahead and do number 2 then now on your own. See what happens. What happens in that one? Okay, who's willing to share? What transformation occurred from f of x? By the way, is f of x equals x the parent function in this one? Yes or no? Is f of x equals x? I want you to get so you're just going to be like, as soon as you see that, you say, oh, there's the parent. Okay, Lindsay, what happened?
Translation of moving the top.
Yeah. It was a translation because only the y-intercept changed. Only the y-intercept changed. And and it is 3 units up. Now, what I'm forgetting to have you do is I'm sorry, I should have had you do this. I want you to identify the slope and the y-intercept for each of them. So what's the slope for the f of x equals x? 1. What's its y-intercept? 0. What's the slope of the g of x function? What is it? 1. And the y-intercept is? -4. Okay, when we identify those, it makes it easier for us to see. You know what? The slope did not change. If the slope does not change, I know that either a rotation or a reflection could have happened. The only thing that could have happened is a translation, possibly. So I ditched the 2R transformations and say, well, let's check it out and see if there's a translation. If it's a translation, then the y-intercepts changed, and they did. Went from 0 to -4. That's why we say 4 units down. Let's do this over here, too. You're going to get, so with the parent function, you're going to kind of write that without even thinking, as long as it's the parent function. M equals 1, B equals 0. How about for our g of x function? M equals 1, B equals +3. Thus, y slopes did not change, so it had to be a translation of anything. Y-intercepts did change, so it is a translation, and the y-intercept changed by going up 3. Okay, go ahead and do number 3 now then. Let's do M and B first for both of them. M, B, and then on the line below that, describe what you think happened from f of x to get to g of x. Okay, who's going to share? You're convinced you got this, you're ready to come up here and teach it. Did the slopes change? So what 2 transformations can we throw out right away? Rotation and reflection. Okay, so now we're down to just a translation. Did a translation occur? Did the y-intercept change? It did, didn't it? So what? Okay, so translated. Okay, now comes the bravery. How many units in what direction? 7 units. What did you say? Down. Went from +5 down to -2 on the y-axis. Let's go put these in our graph. So take the parent function out of y sub 1 and put in our x plus 5. In y sub 2, put in our x minus 2. The one that is crossing above the x-axis should be our first one. The one that is crossing below the x-axis should be our second one. And how can we verify that it translates 7 units down pretty easily? What do we have to do what would you do on that graphing calculator? Count how many units between where they're crossing the y-axis. So go ahead on your count. How many units did it go from where it's crossed, from where the one at the top, our first function, is crossing versus where our one below is our second function is crossing. Are there 7 units between? And what are these lines parallel? Of course they are. Why? Same slope and different y-intercepts. Of course they're parallel. Yes. Okay. Anybody have any questions so far? Do you understand what needs to be shown for these tomorrow in your homework when you're doing them? Okay. So again, right away before we even, which I should have done right away, have it immediately. Let's do this every time because that's going to help us decide what transformations occurs. Okay, so turn those gravity calculators off for a moment, and let's do this without them. This is the parent function, so I say, oh, that's the parent function, I know that's m equals 1, b equals 0. The transform function g of x, what's its slope? 4. And its y-intercept? 0. Okay, did the slopes change this time? Yes. So now we have to go and say, could there have been a reflection or a rotation? Which one do you think it is? Rotation. Because the reflection is when it's multiplied by what? -1. And it didn't go from positive to negative or negative to positive, did it? So this is probably a rotation. So we're going to say rotated. But when we talk about it rotating, we have to talk about that the line, whether it got steeper or not, and what did it rotate about. In other words, when it rotates, it has to stay fixed on a point. Okay? So it can't, one point has to stay somewhere. It has to stay fixed on that point. That point is always going to be the y-intercept. So what's the y-intercept of the first function? 0. So we're going to say it rotated about meaning, not approximately, but about. It's saying this is the point that's going to stay fixed, 0, 0. It's crossing at the origin. Its y-intercept is 0. And is, so in other words, this line is going to have this same fixed point, but did it get steeper or less steep? What's the absolute value of 1? 1. What's the absolute value of 4? Which one's larger? So did it get steeper? Yes, it got steeper. It went from 1 to 4. It got steeper and is steeper. So when we describe a rotation, we have to talk about what point stayed fixed, and is the new line steeper or less steep than the first line. Now, did the y-intercepts change? Because we have to look for that too. Did the y-intercepts change? No. Since they didn't change, that means there was not a translation. Okay, we're going to look for all those things. Okay, number 5, go ahead and do it. What do you think that one? Willing to share. You got this. Who's got it? Willing to take a stab at it anyway. Steve, thank you.
It rotated about 0, 0, and is not as steep.
Okay, so it rotated, the slope changed, and it rotated about the fixed point, which is the y-intercept of the first one. So it rotated about 0, 0, and is less steep, you said?
Yeah.
Okay. You guys agree? He's right. It did. It rotated because the slope changed. And it rotated about 0, 0, the y-intercept of the first function. And 1/3 is smaller than 1, so it is less steep. Okay, now go do the number 6. You got this. Cameron, what do you got? Well, maybe you should wake up and do it then. Because I'm not going to let you do that. Okay, who's willing to share? You can't be taken. You can't do it all. Come on. What you got, Benton?
Rotation, spot at the origin, steeper.
Anybody agree with it? I think we all should. The slope is the only thing that changed. The y-intercept did not. The slope changed, and it's going to rotate about the y-intercept of the first function. And you compare their slopes. It went from 3/5 to 7/3. So is 7/3 greater than 3/5? How do we know that without even like comparing them with common denominators? 3/5 is what? Less than 1. 7/3 is more than 1. So it did get bigger, didn't it? Okay. So any questions? Okay, well guess which next one's going to probably show up next. Reflection. Which, Riley, are you using a phone there? Okay, thank you. Okay. So we will do the same thing. We will go m equals, b equals, m equals, b equals. So m equals 1, b equals 0. That's the parent function in this one. G of x equals negative x. M equals negative 1. B equals 0. Okay. Did the y-intercepts change? That's always the first thing I look for, kind of usually. But did the y-intercepts change?
Yeah.
No translation. They're both zeros. Okay. Slope. Did the slope change? Yes. First thing I'm going to look for is if they're opposite signs, I'm going to check to see if you just took the first one times negative 1, would you have the second one? 1 times negative 1. 1 times negative 1, is that negative 1? Yes. So what happened here? Reflection. When the slopes when the first slope gets multiplied by negative 1 to get the second slope, we say it is a reflection, and the only thing we have to say here is across y-axis, okay? Because that's the only kind of reflections we're going to talk about. So we describe it as a reflection across the y-axis. Okay, moving on, let's go to number 8. M equals B equals. Is the first one the parent function this time? Is the first one the parent function this time? F of x equals negative 1/2 x? No, what's the parent function? F of x equals x. Get that down. But we can transform other members of the family. It doesn't always have to be the parent function. So we're not starting with the parent function this time. We're starting with another function that does not have a slope of 1 and a y-intercept of 0. It has a slope of negative 1/2 and a y-intercept of 0. The transformed function has a slope of 1/2 and a y-intercept of 0. Again, you say, one is negative, the other one is positive. So the first thing I'm going to check for is if I multiply by a negative 1, would I get the other? Negative 1/2 times negative 1. What's that? What's negative 1/2 times negative 1? What's half 1? 1/2. And what's a negative times a negative? A positive. And does this one have a positive 1/2 slope? What? Right there? So it went from here to there. Is negative 1/2 times negative 1, 1/2. I guess we're not seeing this. So this is a reflection again across y-axis. Okay, why don't you go over that in the graphic calculator and just verify it? Come on, go through it. So in y sub 1, we're going to put negative 1/2 x. Remember, use the negative key down there by the enter key. Parentheses 1 divided by 2, close the parentheses x. In y sub 2, put a positive 1/2 x. Press graph. And do you have an x on your graphing Yeah, kind of a spread out X, because is the slope very steep? No. Okay. But do they have the same, I mean, in reality, are they both rising and running at the same amount, just one of them's in the negative direction, the other one in the positive? So the only thing that happened is the reflection. Okay, now let's move on to, we gotta get going. M equals B equals, M equals B equals. So for the f of x function, what's its slope? 2. This should not take us very long to answer anymore. What's its y-intercept? -1. What's the slope of the g of x function? -2. And the y-intercept? 3. It's looking to me like there's maybe a couple of things that happened in this one. Because not only did the slopes change, but also the y-intercepts did. So what's one thing that happened? Anybody know what one thing is that what happened in this one? A reflection, okay, because it went from +2 to -2, so there's a reflection. And when we talk about reflections, they're across the y-axis always. That's what we're going to be, when they get multiplied by -1, when the slope gets multiplied by -1, it reflects it over the y-axis. Okay? So that pretty much takes care of the change in slope, doesn't it? How about the change in the y-intercept? Translation, okay, and it got translated. Remember, we got to talk about how far and what direction. So it went from -1 to +3. 4 units up. Went from -1 to +3, so it means it went up 4 units. And if the y-intercept goes up 4 units, so does every other point of the line, okay? Okay, number 10 is kind of tricky, but let's just get our M and B's identified first, so I can help you understand how to do this one. Okay, so M equals -1/4 for our f of x function and B equals 0. M equals a +1 and B equals a -2 for our second function. Okay, notice there's a couple of things going on. Well, there's 3 things going on actually. It went from -1/4 slope to a +1. But if you took -1/4 times a -1, what would you get? +1, right? Okay, so +1/4, not a +1. -1/4 times a -1. So when the slopes are not just, hear me on this, okay? Tune in. When the slopes are not just opposites of each other, like they were up here. When they are not just opposites of each other, that means, but yet they're opposite signs, that means both a reflection and a rotation happen. So to get one to be positive and the other one to be negative, and they're not opposites of each other, we have to talk about both the R's. So we're going to first say there had to have been a reflection to get it to change from negative to positive. So we're going to say a reflection across the y-axis. And then the other thing that affects slope is a rotation. So we're going to talk about a rotation. And remember, with a rotation, we have to talk about what point did it rotate about, and is the new line steeper or less steep. So it always rotates about the y-intercept of the first one. So it's going to rotate about 0, 0 in this one. It won't always be 0, by the way, but it just happens to be the ones we practiced are. It's going to rotate about the y-intercept of the first one, as long as we do the rotation first before we do a translation. And we have to talk about its steepness. So what's the absolute value of -1/4? How far is it from 0? 1/4. What is the absolute value of 1? So is 1 larger than 1/4? It got steeper, didn't it? But we're not done yet because the y-intercepts also changed. Went from 0 to -2. So what happened? Translation, and when we talk about a translation, we have to talk about how far and what direction. So it went from 0 to -2. 2 units down, right? Whew, there's all kinds of things going on in that one. Trust me, there's a whole lot more transformations we could talk about. We only have to talk about these 3. That's the good news. Questions before we go on to that last one? This is tricky stuff. It makes you think. Okay, number 11. Write a function, in other words, a new function, g of x, to describe the new graph. We are to reflect f of x equals 3x minus 7 across the y-axis and translate it 7 units up. So let's just take our f of x equals 3x minus 7, and let's talk about its m and its b. What's the m value for that one? 3. And its b value? -7. And we're supposed to write a new function, g of x, and it has to be reflected across the y-axis. So first thing we have to do, to be able to reflect, we have to mess with the slope, don't we? For a reflection, what do you have to do to that slope? Multiply it by a -1. So our g of x function is going to have a -1 slope, isn't it? For the reflection part across the y-axis. So it's going to have a -1x slope. Or -1, not -1, negative, thank you. Yeah, I'm always happy when I look out and you guys got your faces scrunched up because I'm like, I said something wrong. Okay, -3x, the opposite of 3. Basically for a reflection you need the opposite. So the opposite of 3 is -3. And then it got translated 7 units up. So it went from -7, 7 units up. Where's it at now? It's at 0. So plus 0. So now we'll just clean that up and say our new function is g of x equals -3x. Whew, is that enough information? Okay. You know, shoot this piece of paper, get your assignment written down, that's all you have time for. I'll get your graphing handout to you, and you need to return the graphing calculators.